So with that thought, আমাদের সাথে এখন আসবেন আমাদের second keynote speaking নিয়ে. The keynote speaking topic is embracing cloud native mindset. The presenter is our own Sheikh Rubabuddin Osmani. He came from Chicago, USA. By profession, he is a senior software staff engineer in Grainger and co-founder at KloverCloud. KloverCloud is our platinum sponsor. So I would like to request Sheikh Rubabuddin Osmani bhai.
Hello everyone, thank you. Thank you KCD for arranging such an amazing event. This view is really amazing. I always dream করতাম যে if we have a Kubernetes community in Bangladesh, মানে আপনারা সবাই এখানে এসেছেন দেখে খুব ভালো লাগছে। আর can we have a big applause for the KCD organizer, please? Thank you, thank you. So আমি আজকের টপিক হচ্ছে embracing cloud native mindset. So কিছুক্ষণ আগে তপু ভাই বলে গেলেন about cloud native technologies, right? So I'm going to talk about cloud native mindset. Actually, cloud native technology, by embracing cloud native technologies, is not only going to, it's going to make your application go to cloud, but it's not going to make you to adapt cloud for your performance improvement, or for your application performance improvement, right? So you need to have a cloud native mindset to improve your application performance, or maybe innovate and grow your organization, right? So something about me. So I'm Sheikh Rubabuddin Osmani. I live in Chicago, Illinois for last 15 years. I'm a senior staff engineer at Grainger, also a co-founder of KloverCloud. I used to be a tech lead at Expedia as well, so I have like 14 plus years of experience in cloud native technologies and cloud platforms, right? So let's go to some statistics in 2023. It's a GitHub contribution statistics. So if you see here, right, so we had a huge contributions from a lot of developers, a lot of open source communities, and because of their contributions, the open source technologies are going ahead, right? So without their contributions, we will not be in this place today, right? Right now, generative AI models, they are, like very huge popular, right? So we have recently, the Llama 2 that made open source. So that is also getting very popular. So this is the number of public repositories with Docker files on GitHub. So if you see here, right, so after 2017, the growth to have Docker files in the repositories went like exponentially high, right? So that means we are basically building our applications or contributing our applications for cloud native purpose. So let's see where Bangladesh in GitHub statistics, right? So if you see here, these numbers are from Q3 2022 to Q3 2023, right? So Bangladesh is doing amazing. The percentage growth of active accounts in Bangladesh is the top one, right? And Bangladesh is the number 5 of having active developers. So which is great. This is the way to go. I'm really proud of that, right? Now, we are developing a lot of open source technologies. We are contributing towards open source technologies, right? But it's not only that, right? So we need to make sure whatever applications that we are building, the application is actually able to scale and perform better, right? So I'm not going to talk about what is cloud computing. So why we need to go to cloud computing. I'm not going to talk about that. Because we all know that moving to cloud is much better of just running on bare metal or VM, right? Let's talk about what are the characteristics of cloud computing. So these characteristics being provided by NIST, which is the National Institute of Standards and Technology, which is a federal government agency in US, right? And the first one, very first one, is on-demand self-service, right? So on-demand self-service, what do we mean by that? Why on-demand self-service is a characteristic, it's the very first characteristic of cloud computing. Because cloud computing wants you to move faster. It's not only you are abstracting your application infrastructure, it's also make you able to move faster. That's why we need that on-demand self-service. So there are a lot of other things like broad network access, resource pooling, rapid elasticity, measure service. I'm not going to focus on that. I'm going to first focus on-demand self-service. So why do we need self-service? Think about staying in a line, right? Staying in a line in a grocery store. And you are waiting for the, whoever on the other side, like cashier, to progress faster, right? But you are being bored on waiting on that line. You are actually losing your time on waiting on the line, right? So if you have these automated cash machines, like where you can charge your credit cards or pay by yourself, simultaneously all of the, maybe 10 customers can do it by themselves. And the line, you don't even have to wait for that much longer in the line. So that means self-service increases productivity, right? But what are the challenges of self-service in that cloud? What comes with that challenge, right? So the first of all is security concerns. There are a lot of security concerns, right? Because if you have hundreds of developers in your company, then you should not let all the developers to access your infrastructure or your cloud premise, right? Because then any developer can do whatever they like. So for that security concerns, there is challenge. There is challenge of resource management, cost control. How do you control that cost? If you have given access to your AWS console to your hundreds of developers, you don't know what they're spinning off, right? So your cloud costs go exponentially high. There are governance, compliance issues, data privacy, sovereignty, integration, scalability challenges, user access management, a lot of different other challenges, right? So how do we solve this challenge? Anyone? How do we solve this challenge? Okay, the solution is platform engineering. So this is, I think, this has been there for a longer period of time. But in Bangladesh, I have seen very rare adaptation of platform engineering. So if you think about what is platform engineering, it's an internal developer platform that we need. So what this platform does, treat the platform as a product. So when your company provides you a platform, or your company's platform engineering team provides you a platform, that platform engineering team should treat the platform as a product. Or your company should also treat the platform as a product. There should be huge focus on that platform, because that platform enables your developers, enables your software engineers, right? So this platform is purposed to solve internal developers' need, right? So whatever developers that, whatever need the developers has, this platform tries to solve those problems. And these platforms automate and enable self-serving, right? So with all the compliance, all the challenges, it tries to solve with that self-serving. So just a quick question. Can you guys show hands who has a platform engineering team in their organization, in their company? I see one hand, 2, 3. Okay, very few. So that means we have a lot to do it here, right? We have a lot to do here. That please tell your companies, leaders, to think about that, right? Don't be scared. Just talk about that, why we need platform engineering, why you need a developer's platform, right? Okay, so these are the benefits of platform engineering, right? So if you think about it, I don't know if you can see it, right? So in the middle, there's platform engineering, and this platform engineering deals with all these things: data, AI, ML ops, policy governance, security, secret, auth, identity tools, container orchestration, observability tools, infrastructure as code, CI/CD, pipeline workflow, DBAS, database as service, right? And on top of that, what this platform engineering team does, it provides an internal developer portal with the CLI, API, and proper documentations. And this portal and CLI and API being used by different teams, right? So these are different development teams, and they are using this platform to build and run their applications, right? So this is where, all these development teams kind of benefits using this platform. And these are the platform engineering benefits: infrastructure abstraction, standardization, consistency, automation, efficiency. So whatever the challenges of that self-service cloud infrastructure was, so all this platform engineering can solve. Now, let's talk about that. How do we, improve our organizational performance? So teams that recognize the need to continuously improve and tend to have higher organizational performance, right? So you need to have a always learning mindset. So if you know that, okay, I'm doing fine, but I can do better. If you think about that, I can do better, right? Then your team's performance can be improved. So don't always be complacent about you are, wherever you are fine or you are doing great. So always try to do better. Try for better performance. Now, how do we measure this performance? There are 3 different kinds of performance that we can measure. And this is for, very important for leaders to observe these performance metrics, right? So one of the performance metrics is software delivery performance. Another performance is the operational performance and organizational performance. Now, for software delivery performance, this is very interesting and this is very important as well. So if you have heard about DORA, can anyone tell what DORA is? What DORA stands for? So it stands for DevOps Research and Assessment, right? So using DORA, 4 key metrics being measured for software delivery tracking. The number 1 is the deployment frequency. How frequent you are deploying to production. Then the second one is the lead time for change. So what is lead time for change? When you are committing your application code to your Git repositories, from that time, how soon you are going to production. That is the lead time for change. Then the change failure rate, right? So how frequently your deployment or your build is failing and your deployment is failing. That is the change failure rate, right? Time to restore service. So when you go to production, so how many times you failed in production? So that is the, and then, how long it took for you to roll back that application or deploy, another successful deployment. So those things are pretty necessary. So you can all do that if you have a internal development platforms. Then operational performance. So you need operational performance, right? So reliability or availability. So mostly SRE. So we have SREs, they kind of take care of that operational performance, how reliable and how available your applications are, right? Then organizational performance, how well your organization meets performance and profitability goals. And organizational performance kind of depends on the other 2 performance, the software delivery performance and the operational performance. So what is the elite performance? So this is like 208 times more frequent deployment than the lowest performance. That is the elite performance. There are other statistics as well. So how we are going to increase the software delivery performance? So the first thing is adapting the DevOps culture and CI/CD, right? This is, I think, a lot of companies in Bangladesh, they are right now adapting DevOps and CI/CD, which is great, right? Then with that DevOps and CI/CD, there is a strategy which we call shift left. Have you guys heard about shift left? What is shifting left? Shifting left is whatever testing and security measurement that you do before production or after production, right? So you should do it on the beginning of your CI/CD pipeline, right? So suppose like you do an end-to-end test, right? Before going to production or after going to production. So end-to-end test, that should be even like after deploying to dev environment. Suppose you have 3 environments, dev, staging, QA, 4 environments, dev, staging, QA, dev, QA, staging, and production, right? And then after deploying to dev, you can do a end-to-end test, integration test, functional test, a lot of different other testing. With microservices, there are contract testing as well, right? So you need to have pact between those services as well. So you need to do contract testing. So a lot of different kinds of it. You should do those different kind of testing in the beginning of your CI/CD pipeline. Then loosely coupled architecture, which is microservices, right? So I'm not going to talk about microservices here. Then we have a trunk-based development. So trunk-based development is it's kind of, sometimes it's risky, sometimes also it enables your team to perform faster or provide features faster. So trunk-based development is you directly commit into your main or master branch, right, without creating a pull request. But if you do that, you need to have a lot of different things to be taken care of before you commit to your master or main branch, right? So you should have pre-commit hooks or pre-push hooks in your code so that you run all the testing jobs, all your security scan jobs on your machine first before you are committing to main, so that your main branch is not failing, right? Then there are other issues as well, because you are not making it available for code review, so you need to do pair programming. So trunk-based development, for trunk-based development, you need to do pair programming, right? Then we have cross-functional team. So what is cross-functional team? I'm going to explain a little bit later. Let's talk about DevOps adoption, right? So this is our conventional thinking that what is production issues, right? So when we have production issues for our application, I'm a software engineer by myself, right? So when I deploy my code to production, there's some production issues. Now, am I going to delegate that to the operations team, right? If I always delegate my problem to the operations team, then operations team doesn't have any time to innovate, right? So operations team can be, innovating something new, right? Other than dealing with others' problem. So my problem should be my problem, right? So if you see Amazon CTO, right? He said, you build it, you run it. So whatever you are building, you should run it and you should manage it by yourself. That is the DevOps mentality. You should not have a separate DevOps team. Each developer should be their own DevOps, right? So that is the mentality that you need to have. So what is cross-functional team? We have a lot of functional silos in different companies, right? So there's a QA team, there is a UI team, there is there may be DevOps team, operations team, and a lot of different things, right? Now, if we think about those functional silos, so each team, so we have a product team, suppose. Product team's responsibility is to work on building features or development on building features, right? Now, that product team talks to QA team, then they go to DevOps team for deployment. If they need infrastructure, they need to talk to infrastructure team. So there are a lot of different functional silos. We don't want to have that functional silos. That kind of delay your progress, right? So we need to have a cross-functional team. So suppose each team, each product team, should have their own QA, should have their own UI engineers, should have their own DevOps, should have their own, like infra team, or platform team, or not platform team, but infra management system somehow. If they use platform, they don't even need that, right? So cross-functional team going to increase your productivity a long, long way. Also, if you think about the business scoping purpose, right? So when we are scoping some business features, we're planning some business features, right? So our traditional approach is to use a Gantt chart, right? So use a Gantt chart to provide like a timeline that this is when the product will be delivered. But instead, if we do that, if we always try to, whatever the design that comes in, we work on that, we do some testing, we get feedbacks from our business stakeholders, and then we again work on that. It's kind of like a loop, right? So whatever requirements that we're gathering, we are working on it, and then we are testing it. Also, we are gathering feedbacks from different business stakeholders. And there we are seeing the improvement. It's kind of like Agile and Kanban, how Agile and Kanban works, right? So this is what we do. We build, then we measure, then we learn again, and then this is kind of like a loop, right? So whatever we learn, we try to build again, right? So we need to do that. And this is my presentation. So think about that. Think about it's not only about technologies, it's also about how you are thinking on adapting cloud-native architecture, right? So if you don't have that cloud-native mindset, then probably you can go to cloud, but your application may not be using all the benefits of the cloud, right? So my humble urge to all the leaders sitting here, right? So think from a different perspective, like take a bold step and come out from that conventional way of development, right? So think about how we can better perform as a team, as an organization. Okay, I'm going to finish it here, right? So, and also my humble request to all the engineers and developers here, so that, talk to your managers, talk to leaderships about what you think. Don't be scared, right? Don't be scared about, like expressing your thoughts. So I think it will be much better when your leaderships, knows about your thoughts and knows about your, like what you guys actually need to perform better. All right, yeah, that was my presentation. Thank you so much for attending here.
I would like to request organizer Tinam Bhai and Arif Bhai once again come to the stage to give the crest to Rubab Bhai for token of appreciation.